Welcome back, and this is the second in the series of videos looking at moles 3. And we're going to be going on in this video to practice more of those calculations. You need to get very comfortable with the moles equations, using them and rearranging them. So we're going to start on your notes on page 8. So in our first example, we have a volume of 2 decimeters cubed, a 0.1 molar solution, and our solute is sodium chloride. So to work out the moles, we're going to use this equation, which you need to learn, which is moles is equal to the volume in centimeters cubed divided by 1,000 times the concentration. So the mass, we're going to work out in the next column, and that is using the equation mass is moles times mmR or RMM. So that's the moles times the RMM of sodium chloride, which is 58.5, to give us the number of grams. And we're just going to do that all the way down that page. And again, just looking at a couple of examples on the next page, we have volume, we have mass. We're going to work out the concentration in moles per decimeter cubed. We do that by working out the number of moles, mass divided by mR, and then working out the concentration, which is number of moles times by 1,000 divided by the volume, which is 250, and that gives us 0.1 of a mole per decimeter cubed. So we now know several different ways of calculating the number of moles. And if you remember right back to moles 1, we said that a balanced equation gives us the molar ratio. It doesn't actually relate to mass or volume or anything else. So moles is a key concept in chemistry, and these are all the different ways that I can calculate it. I can then use my molar ratio from my equation to work out the moles of a reactant or a product, and then I can turn that into a mass or a number of particles or a volume of a gas or a volume of a solution, and so on. So it's a really useful and key analytical tool. So these are formulas that you need to know. So if you were asked to work out the number of moles of a solid, it's going to be the mass of that solid divided by its RMM or its RAM. If you're asked to work out the number of moles of a solution, it's going to be volume in centimeters cubed, because that's how volumes are usually given, divided by 1,000 times concentration. If you're asked to work out the number of moles of a gas, it's going to be volume divided by the molar volume, where both volume and molar volume are either measured in centimeters cubed or decimeters cubed. For pure liquids, we can work out the number of moles using this density idea. So mass is given by the density of the solution times its volume. So that gets us the mass, and then we're just going to use this equation here. So for a pure liquid, the number of moles equals the density times the volume, which gives us mass, divided by the RMM again. There's one more that we really should add on at the bottom here, and that's if we're given the number of particles, and here moles is equal to the number of particles. So that could be will be a very large number, divided by the Avogadro number. And we just said L to stand for the Avogadro number. So if we have 3.01 times 10 to the 23 particles, that would be 3.01 times 10 to the 23 divided by 6.02 times 10 to the 23. So we'd have half a mole of particles. Very similar to the other equations. But it's very important that you're able to use all of those equations and able to rearrange them. So do make sure that you've learnt them. So we're on page 11 of your notes, and we're just going to be using some of these ideas to calculate standard solutions. So we've been asked to work out the concentration given the grams and the volume. So the first thing I'm going to do obviously is work out the moles. If in doubt, if you don't know how to start something, if you're really stuck, the best thing to do is to work out the number of moles of something. It'll always get you a mark even if you can't work out what to do next. So I've got 4 grams of sodium hydroxide, so I know I can work out the number of moles of that. So the moles, I'm going to use my solid equation, is going to be the grams 4 divided by the RMM, which is 40, and that gets me 0.1 of a mole. So I now know the moles. I can use that to work out concentration. Well, concentration is equal to number of moles, 0.1 times by 1,000 divided by the volume, which is 500, so I get a concentration of 0.2 big M, or moles per decimetre cubed. And I'm going to do the same steps as we go down the page. You're going to work out the moles by going mass divided by the RMM, and you're going to use that to work out concentration. We can also use this idea to work backwards to find the mass given amount of concentration. So again, I've worked out the number of moles, volume divided by 1,000 times concentration to give me this. This is the number of moles, and then I've times it by the RMM to give me the mass. In this case, because we're making up crystals which are hydrated, I've got to include the mass of the water. This dot 10 just indicates I've got 10 waters of crystallization. So the solutions which would make a good standard solution, well, the 2 best ones would be the sodium carbonate, the hydrated sodium carbonate, or the hydrated copper sulfate. Why? Because these are pure crystals which are stable. In other words, they don't decompose very easily at room temperature, and they don't absorb moisture from the atmosphere. They also have a high RMM. That decreases the mass error.